Hello again, welcome to my channel. Okay, this session I'm going to talk about VFD control with PLC. So VFD stands for variable frequency drive. We have a live and a neutral. So this is live and neutral lines that should be connected to a inverter input. Okay, this inverter can be a single phase or a three phase. So if it's a single phase, then you just connect this live and neutral, or if you have a three phase system, then you just use the R and RST, then you just use any two of the phases. Okay, that will do. Okay, for this we just want to talk simple how to control. So we have a PLC over here, then we have a relay over here as a start relay and a fast slow relay. Okay, then we have a motor, okay, over here. So PLC, it depends. If you buy a PLC which comes with a AC input, then you can just directly connect and face it. This circuit does not have a circuit breaker, does not have a fuse, but I'm just showing you how this thing can be done. So this PLC will control the start, and this is a speed relay that we have to control the VFD. Okay, so I have not shown here how we connect that is a totally separate subject for DC. Maybe another video session I will show you how this is done properly. Okay, then I'm just going to talk about a bit about the relay, what relay we are using. So this is a slim type we use. Then he has an omni open and omni close contact. Okay, this is the coil where we supply from the controller from our PLC. Either is NPN or PNP. Okay, I'm gonna explain to you NPN, PNP in another video. Then to turn on and turn off the relay. Okay, so this VFD, for this I'm showing an Allen Bradley. It can be any brand, Allen Bradley. It can be Mitsubishi. It could be there's a lot, SEW. There's a lot of company, even Taiwan companies also come up with that. For this, I'm going to show you the Allen Bradley one. Okay, they have for our digital control, we just have to connect to this digital inputs. Okay, now I have two digital input that I need to use. One is to start the inverter to ramp up to a specific speed or a normal speed, and then I have another one which is the you can see here, which is the fast or slow. So if it's on, then it's considered fast. If it's off, then it's considered slow. Okay, use this. So before I was showing you the circuit, so now I'm going to show you the system layout. So basically this is simple system layout that I have, showing how the piping will look like, and this is the pump motor, and this is the flow of the water flow, the fluid flow to the tank, and this is the relay, the valve to go to other tanks or other. Here the pump, I'm showing here the pump, the water direction, how it flows, and then once they start the flow, and then we have this very low level sensors, and then we have the slightly higher, then after he fill up, then he will go to high. Okay, so our programs is going to we're going to write this program when to turn on this pump and when to start the VFD in high speed, running probably in 60 hertz maybe for this example. After he reached the low level, and he runs at the normal speed. So this is what we're going to we're going to write the program. Okay, we are back in our programming environment here. So we're gonna start a new project. So this is okay, we're gonna choose, we have other functions to use, so we're gonna choose this and then click OK. Okay, the rest of it, okay, we're just gonna maintain it as it is. Okay, maximize. So now what we know is we just we want to start the motor in a high speed, or the VFD in a high speed, which is 60 Hertz speed. Okay, so I'm just going to introduce a contact here. I'm going to introduce a normally closed contact. Why is it? Because if you recall back, we want to detect when the low is off, low level, that means it's draining, you can say totally drain the tank. At that time, then we want the pumps to the VFD to start at that high speed. Okay, so we're gonna output with this low tank level, and then we're gonna call this guy. Okay, this one is this output is a high speed, and we're going to latch this one. We're gonna latch this one, and we need to cut off this high speed. Cut off this high speed when the normal speed turns on. Okay, so we're going to introduce another network here. What we do is, before that, there's one more that output that we require, which is this, start. Okay, and we're gonna paste it here. Okay, I'm actually plugging in from my IO list, so you see how advantageous it is when you have an IO list. Then you do not need to type in, so you can always just copy and paste it. And then the output, I'm just gonna start. Okay, this is just want to start the pump. Okay, and we're gonna latch it. Okay, then we have another normally close. Okay, this is essentially the high level, so we need to stop the whole process. Okay, so we don't want the tank to be overflow and that type of problem. Okay, this network is done. We're gonna add another one, perhaps the last one is just gonna use that LL, and then if LL is on, tank level is on, and then if above that sensor is on, then we're going to introduce a timer. So we're just putting T on, and then we call it on delay. We call this one as a on delay. Okay, and we have this 2 second. We're just going to use 2 second time, and we put an output here. Okay, So this is our program. We can start to select the simulation mode, and we log in and we run the PLC. So you see, when we run the PLC, the start is already triggered because the low sensor is off, so you will turn on the start. Okay, the pump will start and the pump will run at the high speed mode. So we can set at any speed, okay, any speed that you desire. So for this example, as I said before, we are setting it at 50 or 60 hertz, and just see when low levels turns on, nothing happens, still at high speed mode, and when low level turns on, and you can see there's a changes here. Okay, there's a changes here. You see the high speed sensor, sorry, the high speed output is off. Okay, so the other relay, which is going to change the speed of the inverter or the VFD, will turn off. So the VFD will go to another speed that we set, example maybe less than that, or maybe 30 hertz or 20 hertz, depending how are you going to test it. So anyway, we're going to test this. Okay, and then when it reaches the highest level, then the whole process stops. Okay, so this is the flow that we have. So apparently the programs works as we intended. So what if the tank gets low, the output valve is turned on, being used by other system or other processors. So just say we're gonna illustrate that one. Okay, this one turns off, the VFD is not going to be started, and just say this one turns off also, nothing will happen. And lastly, when the low sensor turns off, then the whole process starts again. Okay, so this is what how you test your program. So prior to your system is up, and you can test at your own time, and to see whether your programs works or not, and then you can simulate. Okay, this is how you do it. Okay, if you like the video, please click the like button, subscribe to my channel, click the notification bell icon, and share.